All right, for number 8, we are given this matrix and asked to find the determinant of the matrix, and then if the inverse exists, to find the inverse. So the determinant is going to tell us whether or not an inverse is going to exist. To find the determinant, and the way that we show determinant is with these straight lines. Instead of the brackets for our matrix, we're going to have these straight lines. It looks like an absolute value symbol. That means the determinant of this matrix. And it's going to be equal to this number times this number. So 6 times 2 is 12, minus this number times this number. So 2 times 5 is 10. And that's going to be equal to 2. So the determinant is 2. We know that an inverse exists if this number is not 0. The only time an inverse is not going to exist for a matrix is if the determinant is 0. So since it's not 0, we can move forward and find the inverse of our matrix. So we have 6, 5, 2, 2. Inverse is denoted like this. It's the matrix and then to the -1 power. So that means the inverse of this matrix. And it's going to be equal to 1 over the determinant. The determinant is 2, so 1 over the determinant is 1/2, times this matrix, but with some things rearranged. We're going to take these two numbers, the 6 and the 2, and we're going to flip them. So we're going to put the 2 up here and the 6 down here. And then these two numbers, we're going to leave in place, but we're going to make them negative. So we're going to make this a -5 and make this a -2. And so our determinant is just going to be, let's multiply this matrix by 1/2, and we're left with 1. 1/2 times 2 is 1. 1/2 times -5 is -5/2. And then 2 times -2 is -1. 2 times 6 is 3. And so that is our inverse.